done factoring before. We've done it in here before. Now, the reason we're going back over factoring again is that it's very useful and very helpful when solving rational equations. So I've chose to do this here several years in a row because factoring is something we've done. We've seen it before. It's nothing brand new. So I think this is a good way to start the semester off with something we've done before, just a refresher before we jump into new material. Now, this one here, this problem is going to take longer than any of the other problems that we're going to do today, mainly because I'm going to go back over the steps again and write those out. Because whenever we factor quadratics, well, the first step in factoring quadratics is factoring out a greatest common factor. If there's a greatest common factor, we want to factor it out. And if we look at this problem here, b squared plus 12b plus 20, is there a greatest common factor between these three terms? Well, we do have this 12 and 20 do have a common factor of 2, but not b squared. So there's not a greatest common factor for this here. There won't always be one, but if there is one, we want to factor it out. Now, the way you went over factoring previously might be different than this here. If that way makes more sense, do it that way. If this way makes more sense, you can do it this way. Because what I do next after that is our two sets of parentheses with three spaces. And really, this three spaces are just to make sure the parentheses are wide enough so we can fit everything in. And for the most part, the way that we do this here and most others do it really hasn't deviated at this point. Now, the next step that I do, especially with factoring, is to find the signs. We want to find the signs of what's going to go in our two sets of parentheses. If the third term is positive, then the signs are the same, and match the sign of the middle term. So if the third term is positive, then the signs are the same and match the sign of the middle term. Now there's only one other case, and that's if the third term is negative, then the signs are opposite. If the third term is positive, then the signs are the same and match the sign of the middle term. If the third term is negative, then the signs are opposite. And this is kind of nice because the way this works out is our third term, our 20, when we factor it, is going to come from the product of these two here. And if they're both, if we get a positive number, the signs either both have to be positive or both negative. So if the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, our signs are opposite. So if we look at this problem here, we have plus 20. So since the third term is positive, our signs are the same and match the sign of the middle term, which is also plus. So our signs are plus and plus. Only have two steps left. Step number 4. is to find the factors of the first and third terms. And the last step is to plug in and check. Now, some of the times we'll do the steps 4 and 5 really at the same time, because if there's only one set of factors, we're just going to plug them in. And our last step is to check to make sure that we got them correct. Questions on this here? So we look at this here. Factors of the first term, we're looking for factors of b squared. Well, there's only one set of factors of b squared, and that is b and b. Since there's only one set of factors for b squared, we're just going to go on and plug them in. Now, factors of 20, on the other hand, there's more than one, because we have 1 and 20. We also have 2 and 10. 3 doesn't work, but 4 and 5. So we have 3 sets of factors for 20. Which one do we want to try first? 2 and 10. We can plug it in, and now that we have everything plugged in, we can check this here. Now, some books say what we need to do is we multiply the whole thing out. But one of the sets of factors I don't normally multiply out is b and b, and 2 and 10. And the reason I say that is there's nothing wrong in not going through and multiplying b and b. Well, our b times b is b squared, yes? Well, where did we get the b and b from? Well, it's the factors of b squared, yes? They should multiply together to get back to b squared. All 2 and 10 are our factors of 20. We should get back to 20, yes? And I'm of the opinion if we don't have to do it, it's an unnecessary step. It doesn't really help in the overall process. I'm for not doing it. Because the main one that's going to change depending on the setup is this here. In this case, our b times 10, which is 10b. And our 2 times b, which is positive 2b. So we get this here. And 10b plus 2b is 12b. Because the main one we're wanting to check and make sure is correct is the middle term. In this case, we need the middle term to be 12b. Is that what we got? So, these are our factors. Questions on this here? Questions on anything we've done so far? Luckily for us, the majority of the time taken to solve this problem was mainly just writing steps down, not so much in actually solving. So let's look at another one. This one here, we have a squared plus 4a minus 32. Yes. Yeah. We're just factoring. So b plus 2 times b plus 10. So if we look at this next one here, we want to factor a squared plus 4a minus 32. Is there a greatest common factor between these 3 terms? No. So we can move on to our second step, our 2 sets of parentheses with 3 spaces. Now at this point here, I find the sign. So I look at the third term, our term without a variable for these quadratics, negative 32. Since the third term is negative, our signs are opposite. So it means one is going to be positive and one is going to be negative. Now at this point here, it really doesn't matter which one we set as positive, which one we set as negative, because in the end we're going to check. We're going to check and make sure we got it right. So we can just set one as positive and one as negative and fix it if we need. Questions on this so far? At this point here, we want to find the factors of the first and third term. So our factors of a squared and 32. Well, the factors of a squared are a and a. There's no other number in front of a squared besides 1, so it's just going to be a and a. Now we do need to find the factors of 32, which unfortunately is not just one set. There are multiple. But one of the factors of 32 is 1 and 32. We also have 2 and 16. 3 is not a factor, but 4 and 8. 5 is not a factor of 32. 6 is not, and that's kind of exhausted the list. The 7 doesn't work also. Now looking at these here, 1 and 32, 2 and 16, 4 and 8, which one do we want to try first? 4 and 8. So I'm just going to plug them in. And again, after we plugged it all in, we're going to check and see if we do get the correct middle term. Our a times a is still a squared. Our 4 times negative 8 still gives us negative 32. Here our a times negative 8 is negative 8a. Our positive 4 times a is plus 4a. And negative 8a plus 4a is negative 4a. Is that the middle term we wanted? Somewhat. Is this the middle term we wanted? No. Almost. It is the correct number, but wrong sign, yes? So we need the sign to flip. So I will flip the signs here. Because if we get the correct number but wrong sign, well, we can just change the signs. It is possible for this here that I could flip the 4 and 8, but that only works because the numbers in front of a are both the same, so that would also change it. I find it easier to just flip the sign, because if the numbers in front of a were different from each other, then we'd have to make sure we get it all set up correctly. But here, just flipping the sign, our a times 8 is now positive 8a. Our negative 4 times a is now negative 4a. And 8a minus 4a is the positive 4a that we wanted. And that's it. Questions on this here? We're going to look at this one here next. Greatest common factor first. Is there a greatest common factor for this one here? No. Kind of one of the giveaways that there's not. As well, the number in front of x squared is 1, or there's not a number written. So we'll have our 2 sets of parentheses with 3 spaces. We want to find the sign. We can look at the third term. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, our signs are opposite. So here the third term is positive, so our signs are the same and match the sign of the middle term, which is negative. So we'll have a negative and a negative. Once we have the signs, we want our factors of the first and third terms. So we're looking for the factors of x squared and our factors of 72. Well, the factors of x squared are x and x. Those are the only factors of x squared. Now the factors of 72 are 1 and 72. We have 2 and 36. 3 and 24. 4 and 18. 5 doesn't work. At 6 and 12. 7 doesn't work, but 8 does. We have 8 and 9. Now, for the most part, we can use a calculator to find most of these factors, going one at a time. Any questions on this here? Which set of factors do we want to try first? 8 and 9. And the last thing we can do is check this here. Because we don't need to so much check our x times x because it's still x squared. Our negative 8 times negative 9 is still positive 72. Here, our x times negative 9 is negative 9x. Our negative 8 times x is negative 8x. And negative 9x minus 8x is negative 17x. So those are indeed our factors. Questions on this here? We feel pretty comfortable with these here so far. All right. Do we want to look at another one without a greatest common factor? Or do we want to move on to greatest common factor? We can move on. Because these here are the exact same. If we did go through and solve this here, we would get x plus 3 times x minus 10 would be our set of factors. And this here would be p plus 5 times p plus 10 if we went through and solved these here. So, the next one we're going to look at here is number 8. 2r squared plus 6r minus 8. So looking at this one here, is there a greatest common factor between these three terms? Yes. And the greatest common factor is 2. So we can factor 2 out of all three terms. And when we factor a number out, we put it out in front of a set of parentheses and divide that number by every term. So we factor the 2 out of 2r squared, we're left with r squared. Plus, when we factor 2 out of 6r, we're left with 3r. And when we factor 2 out of 8, we're left with 4. So when we factor the 2 out of 2r squared plus 6r minus 8, we have 2 times our r squared plus 3r minus 4. But now that we have factored out that greatest common factor, we can move on to step 2, our 2 sets of parentheses with 3 spaces. And the next thing I look for is our sign. And to find the sign, I always look at the third term. If the third term is positive, the signs are the same and match the sign of the middle term. If our third term is negative, our signs are opposite. Well, here the third term is negative, so our signs are opposite. One is going to be positive and one is going to be negative. Now at this point here, we're going to find the factors of our first and third terms. Well, the factors of r squared are, well, r and r, yes? And hopefully we got enough of that over the last 2 weeks. And the other one's the factors of 4. 1 and 4, 2 and 2, r and r, rest and relaxation. No. No. R and R, rest and relaxation. Now, the factors of 4 are 1 and 4 or 2 and 2. Which one do we want to try first? 1 and 4. Okay. And then the last thing we need to do is check. Now the middle term we're looking for this time is 3r, not 6r, because we're looking at the 3r because we factored out the 2. Now our r times negative 1 would be negative r. Our positive 4 times positive r would be plus 4r. And our negative r plus 4r is positive 3r. Is that the middle term we wanted? Yes. If we get something that's not the middle term we want, we can move the numbers around and try again. Let's look at the next one, number 9. 4x squared minus 20x minus 56. Is there a greatest common factor between these three terms? And the greatest common factor is indeed 4. And we can factor that 4 out from all three terms. We're dividing it out of each term. Because if we factor the 4 out of 4x squared, we're left with x squared. If we factor the 4 out of 20x, we have 5x, negative 5x. Because the signs don't change because we're not factoring a negative out. So the negative 20x will just stay negative. We have 5x. Our constant term will stay negative. And if we factor a 4 out of 56, we're left with 14. Now, it is possible to factor without removing the greatest common factor. It just makes it easier if we do it first. Now, the next thing I always look for is signs. We can look to the third term for the sign. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, our signs are opposite. Well, here the third term is negative, so one of the signs will be plus, and the other will be minus. Now we're going to look at the factors of the first and third term. Well, our factors of x squared are x and x. That's the only set of factors we have for x squared. Now, luckily for 14, we do have more than one, but not that many. Because we do have 1 and 14, or 2 and 7. We only have 2 sets of factors. 2 and 7. Okay. We can put the 7 with the negative and 2 with the plus. And if we check this here, x times negative 7 is negative 7x. 2 times x would be positive 2x, so plus 2x. And negative 7x plus 2x is negative 5x. Is that the middle term we wanted? So our final answer is 4 times our x plus 2 times our x minus 7. And that's it. Questions on this here? Are you ready for the next one? Is there a greatest common factor between these three terms? And the greatest common factor is 5. So we'll factor a 5 out of all three terms. So 5 factored out of 5r squared is r squared. Minus 5 factored out of 30r is 6r. Minus. If we factor a 5 out of 135, we get 27, I believe. Questions on this here? Yes. Since there's no other greatest common factor, we'll move on to step 2, our 2 sets of parentheses with 3 spaces. If our third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, our signs are opposite. So here the signs would be positive and negative because our third term is negative. Moves on to step number 4, factors of the first and third terms. Well, the factors of our first term, r squared, would be r and r. We throw it in because there is only one set of factors, so we can put it in its place. Now 27 has a few. We have 1 and 7, 3 and 9. 2 doesn't work, and really those are the only 2 factors. Which one do we want to try first? 3 and 9. And the last thing we can do is check. R times negative 9 is negative 9r. 3 times r is going to be positive 3r plus 3r. And negative 9r plus 3r is negative 6r. Since that's the middle term we wanted, this right here is the correct answer. Questions on these here? We do have 3 more that we're going to do, and these last 3 will go pretty quickly. Now this next one here, 3x plus x squared minus 10. Well, there is something not correct about this. It's in the wrong form. It's just not written in standard form. So the first thing we can do is just rewrite it in standard form. So it's a little bit easier to work, a little bit easier to factor. Is there a greatest common factor? No. 2 sets of parentheses with 3 spaces. If we found the signs, our signs would be what? Positive and negative, because the third term is negative, so the signs are opposite. Because the only way we can multiply together to give our negative 10 is if one of the signs is positive and one is negative. Factors of x squared. X and x. Now our only factors of 10 are 1 and 10 or 2 and 5. Which set of factors do we want to try first? 5 and 2. And we can check this here. X times negative 2 is negative 2x. Positive 5 times x is plus 5x. And negative 2x plus 5x is 3x. This is the correct middle term that we want, so we get this here. Questions on any of this here before we run into the last 2? Now looking at this problem here, is there a greatest common factor? There is a common factor. Is 9 divisible by 6? No. It is indeed 3. Because there is a number that goes into 9, 30, and 6, and it is indeed 3. And we can factor it out. And if we factor 3 from 9x squared, we get 3x squared. Plus, if we factor a 3 out of 30, we're left with 10x plus 2. Now at this point here, it does seem that the factors for the first and last term did get a little small, yes? and especially trying to get to our middle term. Now, for the most part, at this point here, we would have to go through and try to factor every single possible way, and if one of them worked, awesome. If not, we'd have to exhaust every single one. Now, last semester, I did give you all a way, or kind of mentioned a way to actually determine if it is factorable or not. And that's our square root of b squared minus 4ac. Because if we plugged a, b, and c into this here and got an integer, a non-negative integer, we don't have decimals, we don't have radicals, we don't have I coming out of this, then it's factorable. So for us here, the value of b is 10. The value of a in our case is 3. And the value of c is 2. Because this is just coming from our ax squared plus bx plus c. Now at this point here, it doesn't really matter which calculator we grab. We can grab either one. Say second square root. 10 squared minus 4 times 3 times 2. And here we get 2 squared of 19, which is approximately 8.717797887, and it just continues on. So what that tells us is that this here does not factor any further. We can't take it any further than this here. But it is technically factorable because we were able to factor out a 3. So 3 times 3x squared plus 10x plus 2 is the final answer. That's it. Questions on this here? Well, I'm just going to go on and do this, plug this one in. So the last one that we have, I just plugged it in to that form there to see if it is factorable or not. And it turns out we get the square root of 41, which tells us that this one here is it's not factorable, but not factorable at all. Yeah. Okay. So the reason that this works is the b squared minus 4ac is part of the quadratic formula. Interestingly enough, if that part of the quadratic formula comes out to be a decimal, essentially it has non-rational parts of it, we're left with a radical, it means that this is not going to factor, we can't break it back down. Does that make sense? Because we end up with radicals, that means it's irrational. We can't really factor irrational without knowing the answer. If it's imaginary, if what's inside here is negative, then we have imaginary solutions. Right. Now the last one we did that did work, well, we can even look at this one here. Our r squared minus 6r minus 27. If we plug this in, it'd be second square root. Negative 6 squared minus 4 times 1 times negative 27. And it works out to be 12, so it does factor.